One student. So in last lecture, we saw the difference, the basics of the economics of power plant, the different challenges in front of the power plants. Whenever we're going to install the power plants, we have to face some challenges. It may be on technology background or technology side, or it may be in management side. So generally, if we saw the main objective, or we can say the main focus, whenever we're going to plan any particular power plant, is that on its economical aspects. Okay, because we must know that that particular power plant must be a profitable, right? So for that, we have to carry out economical analysis of any particular power plant before installing or before starting any construction of the power plant, right? So whenever we going to carry out the economical analysis, we have to face some challenges, right? So when we considering the demand from the consumer, that demand is going to be changes with respect to time, right? Means during a one particular day, 24 hours, it will going to be changes. At the morning, at the evening, it may be a very high. During the afternoon, it may be less, right? So in that case, that is the variation from the demand or the consumer demand. Also, this load demand is going to depends upon the type of consumer or type of customer to which we are going to produce, we are going to supply the particular energy, right? So it is also going to be change or load, or we can say the demand, which again depends upon the type of the consumer or type of the customer. And next one is that the optimum efficiency, means the working of the power plant. How, as we know, the power plant, the profit will be the maximized when the power plant will run on the optimum efficiency. But it is because of the some reasons it's not possible to run that particular power plant on regularly on the optimum efficiency. We cannot obtain that particular efficiency, right? Because of the various losses which has occurred, right? The different efficiencies, those are the less than the 100%. So we cannot run that particular power plant on regularly on the optimum efficiency. So these are the challenges, and we have to find out the middle way. Okay, middle way which will balance all those solutions to these particular problems. So for that, you must know what are the different concepts which are related to the economics, and which are we have to consider whenever we carry out the economic analysis of any particular power plant. So for that, we already saw these are the different factors which are related to this particular power plant performance on the demand verification. So these factors are useful whenever we study the economic aspect of the particular power plant. That is the load factor, capacity factor, utility factor, diversity factor, availability factor, demand factor, plant use factor. These are the factors, right? These are the different factors which are very useful whenever we carry out the economical analysis. So the meaning of those factors we are going to study, and also before going to those study of these particular factors, we should know what are the different two concepts, right? These are the most important concept, that is base load power plant and peak load type of a power plant. So generally, it is just a classification of the power plants. Whatever the types of power plants we saw, those are the based upon, again we can classify it based upon the energy resources, again based upon its capacity, and it is again based upon the which type of power plant it is. It is the base load power plant or it is a peak load power plant. So before that, you must know what is meaning of the base load, what is meaning of the peak load. Okay, so now you can see here, this one is the load versus time diagram for the particular, or we can say the demand versus time diagram of any particular application. Okay, so it is during the winter. On the and left hand side you will see it is during for the winter season, and on the right hand side it is for the summer season. So you can see on the x axis there is a time, and on the y axis there is a amount of or units of electrical energy or units of power required. Okay, so we can say the power demand will be on y-axis. So when we draw or plot particular graph with respect to time for the 24 hours, from 0 hours to the 24 hours, in that case you will see there is a variation in the demand, right? It will be varies with respect to time. You can see this is the variation, right? So this particular point or this particular session or the time, it is the morning time. or the morning period during which peak electricity or the peak demand is there. Similarly, at the evening time, there is again peak demand is there. Right? So this you can see these are the particular so these are the demands required or the very high peak demands during the evening, morning and during the evening, right? So this maximum demand which is achieved or which is required, it is known as the peak demand. Okay, so it is the peak of that particular diagram or the graph. So it is the peak demand, and as we know, during whole 24 hours we required some basic or we required this much of energy. Okay, this much of energy or this much of power has been having the demand, minimum demand in that particular during these 24 hours of this particular time. Okay, so this one is known as the base load, right? And this maximum demand which is required for the particular time period, it is known as the peak load. Okay, so now whenever we going to install any particular power plant, generally what we do, we first of all find out the requirement of the of particular we first find out the requirement of the consumer, what is the demand, and based upon demand we will going to design any particular power plant. Okay, so here also we going to decide, first of all find out the requirement of the customer. Okay, demand of the power energy of the from the particular consumer, then we are going to plan or then we are going to design any particular power plant. So generally we are going to design a power plant based upon this particular base load, because during the 24 hours of working, we require this much amount of electrical energy, or that particular demand is least demand is equal to base load. So whenever we going to design any particular power plant, we are going to design it based upon this base load, right? Now whenever we design any particular power plant based upon this base load, means what it will produce is continuously going to produce this much amount of electrical energy, or this much amount of power. Okay, now if during the morning session, during the evening session we require a very high demand, okay, demand will increases, it is more than the base load. So in that case we have to install, or we can install the another type of power plant which will give this much of electrical energy, right, or this much of power from base to the peak load. And the main characteristics, or we can say the main objective of that particular power plant is to produce or provide this extra or additional amount of power during the specified time only. That particular power plant is not going to be run for 24 hours. It will be run for 5 to 6 hours in a day. Okay, so that much of only it must be work for that much of duration only. Okay, it doesn't require to run it for 24 hours in a day. So that particular power plant which is used to produce this peak demand, it is known as the peak load power plant, and this respective demand is known as the peak load. Okay, and the base load which is the power plant which is producing the base load or provide the base load, it is known as the base load power plant. So that is the difference between base load and peak load power plant. So whatever the peak demand is there which is given by the particular power plant, it is known as the peak load power plant, and the base load which is provided by any particular power plant is known as the base load power plant. Similarly, during the summer particularly, the peak demand is during the afternoon, right? So during the daytime the peak load will require, or consumer require the maximum power. So in that case, during only during this particular 5 to 6 hours or 7 to 8 hours, the peak load power plant will run. Okay, and other time only base load power plant will be in the running. Now whenever we select which type of particular power plant we can use as a base load and peak load, that is also important, because it is depends upon the characteristics. Now if you look here, for the base load power plant we are going to start that power plant for 5 to 6 hours. We are going to run that particular power plant 5 to 6 hours, and we are going to shut off that particular power plant. Now, the main characteristics or main requirement for this particular base load and peak load power plant is to that peak load power plant must be start in less time, and it will be shut off in very less time. Okay, means if you consider any particular thermal power plant, for starting of the thermal power plant we require 1 to 2 days. Okay, nearly 48 hours. So we cannot use this thermal power plant as a peak load power plant, because to starting that particular power plant we require 2 days. Okay, so in a one day we cannot immediately start or immediately switch off that particular that particular thermal power plant. So in that case we cannot use that thermal power plant as a peak load power plant. Instead of that, we can use the different power plant like the gas based thermal power plant or the gas based power plant. We can use that one as a peak load power plant, because the starting and switching off time for the gas power plant is very less. We can instantly switch off the gas power plant, instantly switch on the gas power plant. It will nearly 5 to 6 minutes are required, right? Similarly, to the solar power plant or wind turbines, we can connect the wind turbine to the generator. We can disconnect the wind turbine to the generator, right? So likewise, we can switch on and switch off those peak load power plant instantly, or we can say the in very less time. So these type of power plants are generally used or generally considered for providing peak load during that particular day or during that particular time. So these this list you can see, these are the different types of the peak load power plants, and on the left hand side you can see these are the load base load power plants. Okay, because the starting this particular power plant, starting of the produced by this particular power plants, and the switch off time is very high in this particular cases. Okay, so generally all those are used as a base load power plant, and on the right hand side list these are used as a peak load power plant. Okay, so you can see, and generally in India, in world also, we are generally using nuclear power plant or coal power plant or hydroelectric power plant as a base load power plant. Maximum, whatever the maximum base load will be provided, or those that demand base demand is provided by this particular power plant. Okay, and its capacity. Again, another aspect we have to consider, that is capacity. Okay, as we know, nuclear power plant, coal thermal power plant, hydraulic power plant, it is having very high capacity. We can build up those type of power plants which is having very high capacity. Instead, these diesel generators, wind turbines, solar power or gas plant, these are the very its capacity are generally less than the other this base type of power plant. So these are we can use particularly as a peak load power plant, and the switching on and switching off time period for this particular power plants are very less when we consider or when we compare it to the other type of a power plant. Okay, so these are the basic list. Now again, selection of the base load power plant and peak load power plant, it is again depends upon various factors like the availability of the working fluid. In the hydroelectric power plant we require water, right? Without water we cannot run the hydroelectric power plant. So in that case we have to consider the availability of fuel or availability of the required that particular resource. Again, for the coal and also for the nuclear power plant, the availability of the fuel is important, right? So the selection from this particular list is again depends upon the location where we required to install the particular power plant, and also the other factors like the cost. Cost is there, right? Again, the different topography of that particular location, etc. So it is depends upon many factors, but the main most important factor is that the capacity and the running on and switch on and switch off time period of that particular power plant. Okay, so based upon that we can choose any of the power plants or the combination of any of that particular power plants, and we can use it for the particular application. Now you will ask, what is the uh, 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 advantage, or what is the advantage of this particular using two different power plants? Can we design the power plant, any base power plant which is provide or which will develop the maximum energy? Yes, we can use that type of a power plant also, which is providing you the maximum amount of power, okay, or which will generate the peak load. But the main advantages when we use two different power plants is that the uh, when we considering to design any particular power plant which will provide you the peak load or the peak load energy, in that case, as we know, it will utilize only for 1 or 2 hours. Okay, म्हणजे means if we considering any particular power plant, we are utilizing that power plant maximum 1 to 2 hours at its full capacity. Otherwise, during other duration or other time, it will running in its less capacity, or it will running in the its part load. Now, whenever the particular power plant running in it on its part load or the less capacity, in that case, it will its efficiency is also going to be high. So it will going to affect on the performance of the power plant and all those particular factors. So that's why also the production cost of the energy is also going to be increases. So these are the factors which are going to affect if we directly design the base load power plant based upon the peak load. Okay, so that's why we are using two different power plants, which is very advantageous. Its overall efficiency is very high, and the we can say the reliability with respect to demand is very high. Okay, so now next that these different factors we are going to we are going to study. Before that, you must know what are the different main terms and definitions. Okay, so first of all, the connected load. Connected load, as name indicated, it is the combined continuous rating of all receiving apparatus on the consumer premises. Okay, means whatever the apparatus we are connected or which are on, those all, when we combine the rating of those particular apparatus or this particular instruments, it is called as a connected load. The total load is known as the connected load. Okay, the demand means what? It is the load expressed in the kilowatt that is drawn from the source of supply at the receiving terminal. Means if you consider there is the one room is there, and in the room we are installed 5 to 6 hundred watts of bulbs, okay, for the lightning. Now in that case, the total connected load is if you consider 5 bulbs of 100 watt rating, it is the 500 watts requirement. Okay, if that particular consumer switch on all the loads, all the bulbs at a time, the demand which is we received, or it will require 500 watts of electrical energy. So that is known as the demand. Okay, now if there is a 5 bulbs, okay, and we only switch on the two bulbs, in that case only 200 watts are watts it's required for that particular bulbs. So in that case 200 watt is the demand. Okay, and another term is there, that is the maximum demand or the peak load. Means what? All the whatever the uh, uh, devices are there or apparatus which are connected, if we switch on all the apparatus, okay, and in that case uh, at that particular point we require a maximum the demands or maximum electricity or the power. So that value of the electricity or the demand is known as the maximum demand. So if you consider there are 5 bulbs and we switch on all the 5 bulbs, in that case the maximum demand is the 500 watt. Okay, or that will be your peak load. So that is known as a maximum demand or peak load. Another important factor or the terms is there, that is the load curve. As we saw in previous diagram, that is the requirement or the demand with respect to time. That particular graph we saw, that is known as the load curve. Okay, that load curve again we can classify it based upon the time period. We can draw the load curve for one particular day. We can draw the load curve for one particular month or one particular year, one particular season. Depends upon your analysis. Okay, so those are known as the load curve, or it is the just a graph of demand versus time. Okay, so this will gives you, or we can define this one as the load curve is a graphic record showing the power demands for every instant during a certain time interval or certain time period. Okay, so that is known as a load curve. Okay, so these terms and definition are very important. You will see these are repeatedly are coming in the next sessions. Okay, Now, first factor we are going to study, that is the load factor. So, if you see the definition of the load factor, it is the ratio of average load demanded to the peak load demanded during a certain period of time. Okay, so we can generally we can define as it is the ratio of average load demand and peak load demand during a particular period of time. That period of time may be a maybe 1 hour, maybe 2 hour, maybe a 1 day, maybe a 1 week, maybe 1 month, or maybe 1 year. It is totally depends on you. We can find out the load factor for month. We can find out load factor for the year also. So it is just a ratio of average load demand divided by peak load demand. Okay, or max average load requirement divided by peak load requirement. Now, how to find out this particular load factor? First of all, the load factor is related to the consumer side. Okay, there are two different sides. First of all, find out uh, there are two different sides. First one is the demand side, or we can say the consumer side, are generally known as the demand side, where the power is going to be consumed. And the second side, which is the supply side, or we can say it is the side which will generate the electricity, right? Means power plant. So this load factor is related to demand side or consumer side. We going to calculate the load factor to the consumer side only. It is not related to the supply side, or it is not related to the power plant. First of all, okay, we can get the relation between the load factor and the power plant. Okay, but it is generally we are using the electrical energy required, or whatever the power required for the consumer side. Okay, so if we saw the formula, that is average load demand divided by peak load demand for the particular period of time. Also, you can write down the load factor as a energy consumed during the particular time period divided by maximum demand particular during particular time period. Okay, now, if we saw the load factor, always its value is vary between 0 to 1. Its maximum value is 1, and a minimum value will be the 0, right? The total capacity of the plant is utilized for maximum period of time. Means if we consider the load factor is very high, the value of load factor near to the 1 means what? We are mostly using or using the total capacity of the power plant. Okay, now how to find out the load factor? Consider there is one house, or there is one consumer. Okay, in the consumer it will having three different bulbs or three different any devices. Now, rating of those devices, consider first device is having 30 watt rating, second device having 100 watt rating, and third device will having 60 watt rating, right? Now we have to find out the load factor. Consider the at particular instant of time, the requirement, or that this particular consumer will switch on, or that particular consumer is only required or switch on these first two devices. Okay, it may be a bulb, it may be a iron, it may be a any different appliance. Okay, so considering for particular 1 hour, first 1 hour, it will switch on only these two devices. So whenever we going to calculate the load factor, we are considering first of all energy requirement, or the average load, or the required load during that particular hour. It is equal to 100 plus 30. So it will be the 130. Okay, that is the requirement at that particular time period. Okay, for the particular 1 hour. Now, the maximum demand means what? Maximum demand means maximum load, or maximum load that particular consumer is going to be applied, or it will going to be connected in that particular circuit. So maximum load means we have to add all these three devices rating. So the maximum load will be 190. So that will be came in the denominator side. So 130 divided by 190, that is your load factor. Okay, this is the connected load, average connected load, and this is the maximum demand. Okay, so when the load factor value will be the one when we are connecting all these three devices. Okay, means what? The maximum demand is going to be equal to the average load demand. So in that case, load factor will be 1 and load factor will be 0 when there is no any load connected in that particular circuit. Okay, in that case, it will be the 0. So load factor value is vary between 0 to 1. Okay, and it is required whatever the demands from the particular consumer side that we have to consider. Okay, now high low factor means greater average load, which means the more power units may be generated from a given maximum demand. The fixed cost, which is proportional to the maximum demand, can be distributed over the greater numbers of power units supplied, and all of the above will lower cost of electricity being generated and the supply. Okay, so this is related to the load factor. Now, second point we are going to study, that is the capacity factor. As we saw, the load factor, in that case we are considering whatever the demand from the consumer side. Now, the capacity factor, it is related to the power plant, actually where the power is generated. So we can define the capacity factor is that it is the ratio of actual output of power, actual output of the power plant over a period of time to its output if it had operated at full rated capacity during the same period of time. Okay, means what? It is just a ratio of whatever the power generated, actual power generated during particular one day, divided by maximum power it can be generated during that particular one day. Okay, so it is related to the power plant. It is not related to the consumer side, right? In load factor, what we saw, it is the ratio of the actual demand divided by maximum demand. Similarly, capacity factor means what? It is the ratio of actual output produced divided by maximum output it can be produced by the particular power plant, or it is a maximum what we can say maximum capacity of that particular power plant during that particular time period. It is all those capacity factor, load factor are depends upon time. That is important. Okay, so we can calculate this, particularly we are calculating this capacity factor to the power plant. Okay, so it is the actual output during particular one day or particular during a particular time period divided by output that could be produced at a rated plant operation. Means if we running that particular power plant at its full capacity for that particular day, for that particular time, so it will give you the maximum amount of power produced by that, or maximum capacity of that particular power plant. So this is known as the capacity factor, and again its value is vary between 0 to 1. Okay, maximum it will having 1 value, minimum it will having 0 value. Okay, you can also using this particular equation to calculate the annual plant capacity factor. Means was the period for this particular capacity factor is 1 year. Okay, similarly you can calculate capacity factor for one day, you can calculate capacity factor for 1 month, 6 months, etc. It is depends on you. Okay, so similarly for annual plant capacity factor, we can use this particular formula. Here only we are using annual units produced divided by plant capacity into the hours. Okay, so that is the thing related to the capacity factor. Now the capacity, as we as I said, capacity factor is applied to the power generation system, and where the load factor is applied to the power user or power consuming system. So that is the most important difference. Okay, you must understand the capacity factor is related, or we can apply to the power generation system जिथे power generate होते. Okay, and the load factor, it is applied to that particular system which will consume the power. Okay, so if you take as an example turbine and all those power plants, we are going to calculate capacity factor. But in the case of fans, pumps, and any other power consuming devices, in that case we are going to calculate the load factor. So that is the two different factors. Okay. Now again, many students will just confuse between the capacity factor and efficiency. Is the capacity factor is same as the efficiency, or it is different? So the capacity factor is not similar to the efficiency. Capacity factor is totally different phenomena, and the efficiency is totally different factor. Okay, so capacity factor, it is related to the particular generation of electricity. Okay, and the maximum amount of electricity it can be generated. But efficiency, it gives you the relation between input and output produced by the particular power plant. Efficiency is not depends upon time. Okay, that is the main difference. Efficiency is not going to depends, or cannot say that for the 1 hour efficiency is that much. Okay, whenever we does not change any input or any particular parameter of the power plant. Okay, efficiency, it will gives you relation between input and output, whereas capacity factor gives you the relation between actual power generation and the maximum power generation that particular power plant can generate. Okay, so we are just comparing the actual power generation by the particular power plant and the maximum capacity of that particular power plant. So the efficiency is a different one, capacity factor is totally different one. Okay, so this is the difference between the capacity factor and efficiency, right? Now there are different types of the efficiencies. You already know those, how to calculate those efficiency. You already calculated for boiler, for turbine, and for other particular components. You already calculated the efficiency. Similar way, we are going to calculate the capacity factor for overall power plant. Okay, this capacity factor we can calculate, but generally in this particular analysis we are going to calculate the capacity factor for overall particular power plant. Okay, so please understand the capacity factor is a different one and efficiency is a different one. There is no any relation between those two particular terms. Now, what is better? Is that higher capacity factor is better, or lower capacity factor is better? So yes, the higher capacity factor is better one. Okay, if any particular power plant is having very high capacity factor, then it is the better one. We have to go for higher capacity factor. Okay, because as we know, the capacity factor will gives you relation between the actual power generation and the maximum power generated by that particular power plant. If we run the particular power plant at very high capacity factor, in that case means what? We are using 100% of potential of that particular power plant. Okay, and it is very useful whenever we use, or whenever we run that particular power plant at its full load, at its 100% capacity. It is very efficient. It will give you the better overall efficiency. It will give you, in that case, the energy generation cost will be very less. Okay, optimum energy generation cost we will achieve in that particular case. So in that case, the whatever the power plant is there which is having higher capacity factor, we are using, or we are going to select that particular power plant. Now again, this capacity factor is depends upon working of power plant. Okay, it is not just constant for that particular power plant, whatever we are changing other factors. No, it is depends on the working of power plant. Okay, so at that particular condition, if we have two choices, one is the hydroelectric power plant, second one is the thermal power plant, and in those two power plants, if hydroelectric power plant having very high capacity factor than the thermal power plant, in that case we are going to choose to build a hydroelectric power plant. Again, it is that hydroelectric power plant, it is other factors also we have to consider, but whenever we compare two different capacity factors, we have to use, or we are going to choose the power plant which is having the higher capacity factor. So if power plant having higher capacity factor, it will be the better one. Okay, so these two factors are important. Those are very important. These are some examples you can use. You can solve those examples. These are the easy examples. Okay, just you have to take the ratios. That's it. Okay, so consider there are 26 main generators, 26 numbers of generators, which is having full rated capacity 700 megawatts each, and also there are two auxiliary generators, which is having 50 megawatts of its capacity. The actual output for 1 year was 79.47 trillion uh, uh, trillion watt hours. Okay, so in that case, you can calculate the capacity factor of that particular power plant. Here you can see the capacity factor we are calculating because these are the power producing devices or power producing systems. If instead of that we are using any particular power consuming system, in that case you have to find out the load factor rather than capacity factor. Okay, so these are the easy examples. You can calculate the capacity factor considering 1 year as a time period or 1 month as a time period, whatever your requirement. Okay, so that's it. This is for today. In the next lectures, we are going to see the remaining factors which are very important.